More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hello everyone, welcome to Mathnasium Schoolhouse. My name is Kevin and today we're going to be talking about quantitative analysis. And I know that name might be a little bit scary, it's two kind of big words, but we're going to talk about the definitions of those words before we get started. So I want to give everybody a little bit of an opportunity to download today's worksheet. We're going to be following along in a similar fashion that we have been the past couple lessons. So give everyone a moment to do that while I get my side all set up. All right. So when we think about the word quantitative, what do we think that means? Before we get into these first couple problems, what do we think that the word quantitative means? I'll give you guys a minute to answer that. So the word quantitative means that we're pertaining to the quantity, or we're measuring the quantity of something. And analysis is that we are examining. So what we're going to be looking at is examining measured quantities of things. And specifically, we're going to be comparing quantities. So let's go ahead and get started. So I want to look at number 1. So for number 1, is 20 plus 30 plus 50 greater than, less than, or equal to 100? And it might be easier to do that if we know how much 20 plus 30 plus 50 is. So let's go ahead and figure that out first. So can somebody tell me what 20 plus 30 plus 50 is? Anybody tell me what 20 plus 30 plus 50 is? Yeah, very good. That is 100. So is 20 plus 30 plus 50 greater than, less than, or equal to 100? Yeah, very good. It is greater than. All right, so number 2. Number 2, 10 quarters and 15 dimes. Is that greater than, less than, or equal to $3? Well, it's hard to compare things when they have different denominations. So on the left-hand side, we're looking at quarters and dimes, whereas on the right-hand side, we're looking at dollars. And if you've been to a Mathnasium, you may have heard one of your instructors talk to you about the law of sameness. And the law of sameness tells us that it's easier to add and subtract, and we actually can only add and subtract things that have the same name. And we're going to use a little bit of an application of that, and it's easier to compare things if they have the same name. So our name on the left-hand side is quarters and dimes, whereas the name on our right-hand side is dollars. So let's get those names to match up, and the easiest way to do that is to figure out how many dollars, how much money altogether 10 quarters and 15 dimes is. So can somebody tell me that? Anybody tell me what 10 quarters and 15 dimes is. $10 is $2.50, and 15 dimes is $1.50. If I add those up, do I have more or less than $3? Or is it equal to $3? It's more, exactly. So we're looking at greater than again. Good job. Very nice. All right, number 3. 10 weeks is how many days? Well, how many weeks are in a day? We know that it's 7. So 7 weeks, 10 times. It's going to give us 70 days. We know that that is less than 100 days. Nice job. All right. And you guys will have to give me just a second. I'm having a little bit of difficulty on my end. So why don't you guys go ahead and start working through number 4 and tell me if 100 dimes is more or less than $10. All right, everything looks good on my end now, so I hope it looks good for you guys. So 100 dimes more or less than $10. Well, I know that 1 dime is 10 cents. So 10 cents 100 times is how much? How much is 10 cents 100 times? 10 cents 10 times gives me $1. And if 100 is 10 tens, then that gets me to $10, so those would be equal. All right. So we're on the second half of page number 1. 10 quarters, 10 dimes, and 10 pennies. Is that greater than, less than, or equal to $10? Let's go ahead and work on getting the left-hand side to be in dollars as well. Easier to compare it that way. So 10 quarters, 25 cents, value of a quarter, 10 times, is $2.50. 10 dimes, we said last time, is $1, and 10 pennies is 10 cents. So if I add all of that up, is that greater than, less than, or equal to $1, $10? Well, just looking at that, I know that we're not even going to be close. So 10 quarters, 10 dimes, and 10 pennies is less than $10. Good job. All right, number 6 is 10 feet greater than, less than, or equal to 100 inches. How many inches are in a foot? How many inches do we have per foot? Yep, 12 inches per foot. Very good. So if I have 12 inches 10 times, it gives me what? Greater than or less than 100. Very good. Greater than would be 120 inches. So looking at number 7. Number 7 is 210 times, the same thing as 10 200 times. It's 200 10 times. 200 times 10, the same thing as 10 times 100. And anybody that has studied a bit of multiplication might have heard of the commutative property, which is on display here. But if we haven't been through that yet, we can do the arithmetic and figure it out. So 200 times 10, 210 times would be 2,000. And 10, 200 times, if I have 200 tens, I also have 2,000, so those are going to be equal. Nice job. All right. Number 8 is 2 years greater than, less than, or equal to 100 days. Well, how many days are in 1 year? How many days are in 1 year? Yeah, 365. Very good. And that's already more than 100, so I don't even have to finish the arithmetic, right? I know that even if it was just 1 year, it would be greater. So 2 years must be greater than 100 days. Let's do number 9. 1 plus 23 plus 35 plus 5,678. Is that greater than 6,000? I don't even want to start doing all this arithmetic yet. Let's see if we can do this with a little bit of number sense and a little bit of inspection. So is it fair to say that 5,678 and 6,000 are pretty close to each other already? I would think so. So in that case, if I just look at my two largest numbers here on the left-hand side, 345 plus 5,678, would that get me to be more than 6,000? Yeah, very good. It would. So does that mean if I add the 23 and the 21 as well, I'm just going to continue to become greater than 6,000? So without even having to do all of the math, oh, and it looks like we're having some issues. Sorry about that, guys. I'm not exactly sure what is happening. Give me just 1 minute. All right. Let's see what we can do. It looks like you guys aren't seeing all of my problems all the time. Not quite sure why that's happening. How's that? Okay, can we see everything better now? I apologize for any issues, guys. I was getting a little bit of problems on my end. I think we've got it all sorted out now. How does it look for everybody? Can we now see problems 5, 6, 7, 8, 9? All right, so I think we got it all worked out now. Okay, so here's what we're going to do. We will go ahead and do number 10, and then I want you guys, after the lesson's done, to go back and do questions 5, 6, 7, and 8. We've got a lot more examples that we can work on, so no big deal, and I apologize for that. I'm sorry. Just having a little bit of issues with my computer here. So let's go ahead and do number 10. How's that sound? All right. So we're looking at 100 minus 50 plus 200. Is that greater than, less than, or equal to 300? We can just work left to right. 100 take away 50 is 50. And 50 plus 200 is 250. Very easily, that is less than 300. Okay. So starting fresh for everybody, we're at the top of page number 2. Top of page 2, okay? And just want to make sure that that is displaying okay for everybody. And we will go ahead and get looking at number 1 on page number 2. So, is 0 greater than, less than, or equal to 1/10? Would you rather have 0 pizzas or 1/10 of a pizza? Is a good way that we can think about comparing these different fractions. Would you rather have 0 pizzas or 1/10 of a pizza? Which value is greater? Another way we can think about it is that fractions are part of a whole. A proper fraction is a part of a whole, and 0 means that we have none of it. We have nothing. So by that logic, 1/10 is greater than 0. All right, so now we're looking at 5/10 compared to 3/6. 5/10 compared to 3/6. So we can try and get these fractions into common denominators, and that'll be the easiest way to compare them. Or we can just think about, what does 5/10 represent? 5/10 is the same thing as saying that we have half, right? We have 1/2. And 3/6 is also 1/2, so those two fractions are equivalent. Okay. Number 3 is 5/8 greater than, less than, or equal to 1/2. Just thinking about that logically, if we're talking about our denominator being 8, or eighths, what would half be as eighths? If I have a pizza and I divide it into eighths, and I apologize for my bad drawing, half of it would be 4/8. So 5/8 is greater than our 1/2. Okay. Number 4 is 4 weeks greater than, less than, or equal to 4 weeks greater than, less than, or equal to 30 days. We said earlier that there's 7 days in a week, and 4 7 times will be 28, so it's less than. Hopefully everybody's following along okay here and that we can see everything. Number 5, 20 quarters and 20 dimes compared to $7. A quarter is $2.50. So 20 quarters is how much money? How much money is 20 quarters? How much money is 20 quarters? Very good. 20 quarters is $5, and 20 dimes. A dime is 10 cents. 20 tens gives me $2. So I have $5 and $2 on the left, and I have $7 on the right. Those are equal. All right, bottom of page number 2. Is 1 whole greater than, less than, or equal to 9/10? And we talked about at the beginning of the page, a fraction, a proper fraction, is a part of a whole. And then on the left hand side of number 6, we have 1 whole, so that automatically, if I have 9 parts out of 10, or if I have 1 whole, that would be 10 parts out of my 10, means that that is greater. All right, 300 nickels, is that less than, greater than, or equal to $10? A nickel is 5 cents. We know that. So 300. 5 times or 5, 300 times is how much? Well, we can think about how many nickels make $1. I know that 20 nickels give me $1. How many 20s are in 300? How many 20s are in 300? Yeah, very good. Would be 15. So it's greater. 300 nickels is greater. All right. Number 8. 667 times 12 compared to 667 times 9. Well, thinking about what multiplication means, I have 667 12 times, or do I have 667 9 times, which is more? Well, I can already kind of think about that 12 is more than 9, and I have 667 in both, so I know that that is going to be greater. Looking at number 9, my fractions again, 7/13 compared to 0 or nothing. A fraction is, we know, bigger than 0. I'd rather have part of a pizza than no pizza, is the way that I always like to look at it. If you guys have been doing Mathnasium Schoolhouse for a while, you might have done the pizza math lesson with me a little while ago, so a little throwback to that. All right, number 10. 13 plus 9 plus 80 plus 40 is that compared to 100. Again, we know that 80 is already pretty close to 100, and 80 plus 40 is 120, and that is greater than 100 on its own. So if I add 13 and I add 9, I'm just going to continue to be greater. So those are all greater than 100. Good job. All right, top of page number 3. Top of page number 3. Is 1/4 less than, greater than, or equal to 1/8? I'll let you guys think about that for a second. So one way that we can look at that is if we have a pizza, would you rather have a piece of pizza that was cut into 4 pieces or into 8 pieces? Which of those pieces is bigger? Right? This slice is bigger than this slice. So 1/4 is greater than 1/8. If I cut something into less pieces, and that's what the denominator is the number of pieces that I cut my whole into, then if my numerator is the same, the smaller denominator is going to be a bigger piece. Number 2, we're looking at 2 different ways of saying half, right? 4/8 is the same thing as 1/2, and 2/4 is the same thing as 1/2, which means that those are equivalent. Number 3. Another bit of multiplication. And we can see that those numbers are the same, they're just in a different order. And again, looking at our commutative property, we know that order doesn't matter for multiplication. We can move those numbers around and we'll still get the same result. So what does that mean for number 3? 2 times 9 is 18, and 18 times 5 is what? We can go ahead and do the arithmetic here and prove this one out. 2 times 9 is 18, times 5 is 90. 5 times 2 is 10, and 10 times 9 is also 90, so we can prove that both of those numbers are equal. 3 weeks is how many days? Yeah, very good, 21, so it's greater. And number 5, 10 quarters and 5 dimes is comparatively what when we're looking at $3? 10 quarters is $2.50. 5 dimes is 50 cents. Very good. Means those are equal. They're both $3. Good job. All right, let's go ahead and do a couple more here. The past ones, when we're looking at fractions, we were looking at proper fractions, right? Where the numerator was smaller than the denominator. So looking at number 6, is that the case on the right-hand side? 11 tenths. What that's saying is I have one more piece than needed to make a whole. Right? We know that 10 tenths would be the whole thing, or all of it. So 11 tenths is one more. It's one more tenth than the whole thing. So is it greater than, less than, or equal to 1 whole? It is greater than. Very nice. 100 dimes for number 7. 10 cents 100 times. 10 cents 10 times is $1. I have 10 tens and 100, which gives me $10 on the left, and those would be equal. Number 8, 321 4 times, or 321 7 times. Just knowing that the first part of each of these multiplication problems is the same, we're really just comparing the second part, and I know that 7 is greater than 4. I know that if I count 321 7 times, I'm going to have more than if I count 321 4 times. I don't even have to do the arithmetic on this one. It's not asking for the solution, right? We're just asking to know which side is larger. Looking at number 9, we know that any fraction is greater than 0. 3/8 is greater than 0. And number 10, none of these numbers are super close to 100, so we'll go ahead and follow through with the addition here. We can do it smart, though, right? If we make 2 different addition problems, I know that 20 plus 30 is 50, and 12 plus 6 is 18. And now if I add those up, well, I know that 50 and 50 is 100, and I don't have that. I have less than that, right? 18 is less than 50, so 100 is greater than whatever is on the left-hand side, and we can figure out pretty quickly that it's 68, but we know that that's less than 100. All right, let's do another couple of these. 25 plus 25 plus 25. Whenever we're looking at 25s, I like to think about quarters and dollars, and I know that there's 4 quarters in $1. If I only have 3 25s, you know that is less than 100, right? 25, 25, and 25 is 75, and that is less than 100. All right, number 2. 10 dimes is $1, and 10 quarters is $2.50. Add those up, I have more than $3. I have $3.50. That's greater. It's 3 months compared to 10 weeks. We don't exactly know how many weeks are in a month, right? It changes depending on what month it is. But for terms of this problem, we'll say that a month is 4 weeks. So if that's the case, I have 12 weeks. Compared to 10 weeks, 3 months is greater. 12 is more than 10. All right, 100 quarters. Well, we said the 10 quarters was $2.50, so if I have that tenfold, right, if I have 10 times more quarters than I did in number 2. That must mean that I have $25, which is equal to $25. All right, last one for now. Number 5. 5 quarters. Let's go ahead and give ourselves a little bit of room here. 5 quarters, 5 dimes, and 5 pennies. Well, 5 quarters is how much? We got to figure that out first, right? Yep, very good. 4 quarters is $1, so 5 quarters is $1.25. 5 dimes. Oops. 5 dimes is 50 cents, and 5 pennies is 5 cents. Does it even get close to $5? No. No, it does not. Which means that $5 is greater than that. Okay, so there are a couple of problems left that I would like for you guys to go ahead and do before our next lesson on Friday, and we can review those. Because I will be back on Friday to continue talking with you guys about quantitative analysis. So I hope that you're excited about that. I do really appreciate you guys joining. If you're interested about what we talked about today, or if you want to know more about Mathnasium, check out mathnasium.com. Find your local Mathnasium Learning Center and give them a call. They'd be happy to talk to you and happy to help you with your math. Really excited for you guys to be able to tune in with us this week. Tomorrow and Tuesday, we're going to be talking about solving proportions, so that'll be really fun. Look forward to the worksheet on that. Otherwise, I will see you guys again on Friday to continue our discussion about quantitative analysis. Thanks so much.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.